Who started recording?
Uh, yeah, I've started. Can you guys see my screen? Can you see my screen?
Yes.
All right.
Yes, yes.
So first things first, I want you guys to go to astexplorer.net. Just enter that. Is anybody familiar with this? Is anybody familiar with this stuff? My check.
Check.
Yes, yes.
Yeah, you're familiar with it. Okay. So for the people who are not yet familiar with it,
Sorry, are you talking of this online?
yeah.
I know some others. You're not exactly the same. No, I'm not familiar with this particular.
Okay, so what it is it's an abstract syntax tree, right? So normally when you write code in the command line, the compiler normally passes through the code and generates a tree, a data structure from this thing.
Yeah, I know.
Uh-huh. So this is a graphical representation of the data structure that is generated. So now, if you look at this, my little code that I've done, this var age equal to 1. So if you come here now, you see the data structure. This is basically the information that makes up this code. So now each part of this data structure contains is a node. Like right now, if you come here, variable declaration, do you see the highlighting of the code itself? Can you see the highlighting?
Yeah. Before
Yes.
you, I just have a simple question to ask. So I want to know where this falls. Is it under TypeScript or
Yeah.
JavaScript?
Okay, yeah. So that's a good question because right now I have selected TypeScript parser here. So TypeScript compiles has some kind of compiler. So I'm using TypeScript parser now to generate an abstract syntax tree from this particular code. So if you go to this, you can set. If you look at it, you will see Babel is ESLint. You see other ones. We are familiar with Babel. So apparently, even TypeScript performs the same function. So now, basically, why I'm saying this is from this data structure that is generated, you'll be able to access any part of a statement made in a code. So like, let's say you come here, where my cursor is, and then when you see the highlighted part of the code. So it's a way of exactly knowing where to access in the code. Now this particular feature you are going to see it as how TypeScript uses it very efficiently. And in doing what it does. All right, so let me create. Hmm? Yeah. But do you want to ask a question now? Okay, those questions, but yeah, I want to do some analysis first before I go there. All right, so make directory.
Sorry guys, please, I need to rush down to the restroom right now. Okay.
All right. Okay. So now I'll create this TypeScript file. So now in this particular one here, I'm going to import from okay. Let's look at our Angular code. So if you look at our Angular code now, some of you may be familiar with this. If you click on command and you click on this, is anybody familiar with this? Hmm? Okay. So do you know why that is? It has to do with that particular issue, that particular thing about the abstract tree. Now, because of the ability of TypeScript to form data structure, it is able to get a whole overview of your project. It means that it knows exactly where everything is in your project because it has created that data structure of every position. So that enables you now to navigate. And if your application is scaling to hundreds and thousands of lines of code, you don't need to start clicking on your folders to look for what position. All you need to do is just press your command and do that, and then you are into the next system to do whatever stuff you want to do. And another benefit of this is, let's say you want to make a change. You want to make a change on a particular variable. Skill service. Do you see this skill service, right? Now, VS Code has its own feature, right? Change all occurrence. Or, oh, okay. I have find, so, okay. Well, like if you want to change, let's say you want to refactor skill service class, okay? And then, but skill service class has been called in like maybe 100 different places, all right? So all you need to do is select it and then click on rename symbol. Once you change it here, any representation of skill service in the application will change. If I do this here, we are going to see the commit area. There's going to be like a lot of changes to be made. So what has happened? What normally happens is TypeScript will go through the whole project, finding that class and its instance wherever it is made, and changes it. You understand? All right. So that's the importance of that.
Sorry,
Yeah.
I have a quick question there.
Yeah.
Is it TypeScript that does the changes, or the editor that we are using?
No, it's TypeScript.
Okay.
I wanted to show something. The editor itself has something like that. But the problem with the editor's own is it is not able to differentiate between an actual variable from a normal text. You understand? So if you want so if you want to change skill service using VS Code, it is also going to change text representation of that in every place. But that's not what you want. You just want the variable. Yeah. So the reason why TypeScript can get that variable is because it has used that AST. It has generated AST from the code. So it knows exactly where each variable and the instance of this variable occurs. All right. Okay. So can still see my screen. All right. There was a small code I was working on before here. So now this code has quite a number of things. first, let me show what the code does. So this is what the code does. Can you see it?
Yes.
All right. So this is the utility aspect of the code here. Now, Babatunde asks a question. Let's go to the question. Okay. All right, so I'll take your number 3 question. What are TypeScript type definitions? All right, so, okay, no, let me just first go with the first one. No, actually, the third one comes first. All right, so now the aim of TypeScript, from the little knowledge I have so far, it is kind of borrowing from strong typed languages, the best parts of strong typed languages, statically typed languages, because JavaScript is dynamically typed. Now, what dynamically typed means is that if you create a variable and call it 1, right? You can assign that variable later a string, right? With JavaScript, this is perfectly valid.
Yeah.
Okay. So, but if you look at this code now, you notice that TypeScript is highlighting this, and it's telling us that this is wrong because it has inferred from your initial definition of the variable that this variable is supposed to be a number and not a string. It has inferred that because it was able to analyze the variable and know what, again, because of ASTs, you understand? So what this does is, when code becomes large and the language is loose in terms of type definitions, some bugs may be difficult to do this thing some bugs may be difficult to ascertain because people might just decide midway through the code to change the type to something else, and you will not know what is happening. All right. So I think the people that decided to do TypeScript experienced that kind of a situation and felt that that feature for statically typed languages was very important in JavaScript if JavaScript is to handle the huge complexities of modern day web applications. And since JavaScript is basically the language of the web.
Sorry, I didn't get you. Said statically typed and
Languages.
statically typed and
Yeah.
what?
Dynamically typed.
So that's what statically typed and dynamically typed.
Yeah.
Can you emphasize more? What's the difference?
All right. Statically typed means that if you say this var Tunde equal to 1, right? And then you define this as a string. In statically typed languages, when you define or declare a variable, you upfront tell whoever may use this particular thing later on that this particular variable should be either a string, number, or boolean, or whatever. And that cannot change. That's the reason why it is called static. Once you put that type on the variable, throughout the whole length of the project and lifespan of the project, that remains what that type is. But for dynamically typed languages, you can midway through a project decide to just switch from number to string, and there will be no error notice. There will be no information to tell you that no, this particular data has been used to do a lot of things as a number. You cannot just midway through this thing just change it like that. Even if the person did this thing consciously or unconsciously, you understand? If it is unconscious, at least if it were statically typed, there will be an error listing at compile time. At compile time, there will be a notice that this thing is not supposed to be like that. Have I answered the question?
Yeah. But another thing I just want to ask is, does this come to okay? So statically typed and dynamically typed.
Yeah.
Well, this is my first time of hearing it, and your explanation actually makes sense. I've heard of strongly typed and loosely typed. So I actually understand the strongly typed and loosely typed. And from the definition you just stated about statically typed and dynamically typed now, I feel like they are kind of related.
Yeah, I think it's the same thing. It's just terminology. Yeah.
Okay.
I'm sorry, just a quick. The reason why I asked that number 3 question was when I was doing React. So I looked at how someone can use TypeScript with React. So and I didn't really explore that, but from what I could glean from a few articles I read. So at that point, when I was looking at TypeScript for React, so I found that TypeScript didn't support React 16 at that time, because for you to use TypeScript to React, you have to install some type definitions. So and at that point, there was no type definitions for React 16. So I just left it. I didn't try to learn anything more about it. So that's why I'm asking the question. So my question is coming from that angle, like, what are type definitions and why do we have to install them? I don't know. That's where that's the angle my question is coming from.
Okay. Yeah. Yeah. From my understanding so far, I think the core of TypeScript is basically that type definition. So, but I don't really understand why it was not available in React upfront, because it should be, because that's the core. That is the very essence of TypeScript. Why it was not available with React, I do not know. But yeah.
Babatunde, sorry, let me chip in. Are you asking of why TypeScript was not included in React? Okay.
That's not what I'm asking. Okay, let me rephrase myself.
Okay.
If you want to do React with TypeScript, you need to npm install some type definitions, and each version of React has some type definitions.
Give us an example.
Okay. Sorry. Okay. So yeah. I'm going to share some links on the chat.
Okay.
Okay, so let's use the second.
Let's do the second link that I posted.
The one with NPM.
No, I posted another link now. Justincredible.net. Let's use that one. So, or should I just share my screen?
Yes, you can.
Okay.
Should I stop my?
Yeah, you have to stop. Can you see my screen?
Yeah.
Okay. Now let me scroll to. Sorry. Yeah. Can you see this heading? Get
Yeah.
start definitions. Okay. So under the heading, it said since React and React Native are not written in TypeScript, we need to download type definitions for this library so that the TypeScript compiler can know about them. So that is my own question. What are those TypeScripts? Type definitions that we need to install. So that was what I had in my head.
Okay, so now can I say something?
Okay. Cool.
Yeah.
All right, so React and React Native was actually written
Can
in
you share
JavaScript.
your screen again, Babatunde?
Okay.
Why do you continue speaking?
Okay. Can you see the screen?
Yeah.
Yes.
All right, so React and React Native are pretty much written on JavaScript, right? So,
Yes.
but the difference between React and Angular is that Angular has a support for TypeScript. So TypeScript is just like a hybrid of the actual language, which is JavaScript, right? So if you wanted to write things like, so what he was trying to explain, like what Trisha was trying to explain earlier was this. If you were writing something on JavaScript, yeah, you know you can actually do things like var this is equal to maybe a string that's just passing the value. But if you're writing things like same thing in probably like Java, you probably don't do something like that. You will have to define like the type, the data type. So we all know that there are things that are called data types. So you have to tell the compiler that, hey, this is a string, and whatever I'm going to be passing into this is going to be a string. So if for any reason or whatever I pass in any other data type that is not a string, you should trigger an error. So that was the essence of them actually doing TypeScript. So when the developers of React, when they were building it, they didn't put in support for TypeScript. So it means that you cannot have a .ts file
Upfront.
in your code. So if you don't have a .ts file, it means that if you write anything like var, take for example var name, and you put a column and you say, okay, it has to accept the type string before you pass in the value, it's going to trigger an error because it doesn't understand that syntax. So you have to install the library like an additional library for you to understand that, hey, okay, you can now use a .ts file in your React application. So instead of using just the way you have GSX, right? So GSX is like an inbuilt library for React, so you can actually write like JavaScript XML kind of files in your React. That's the same way you have to install that. So if I don't know if I explained
Yeah.
your question.
So
Yeah, so
to add to what Louis said, with TypeScript, you are not only installing just a library, you are installing a compiler. You understand? That compiler is what enables TypeScript to recognize types and to know that if you do this, if you define this variable with this particular type and you change it, it will flag. It will show an error, this thing to show that you are deviating from your initial definition.
Cool.
Yeah, thanks.
So to clarify what Richard is trying to say, so like interpreters and compilers, like they do things differently. So interpreters run like line by line. Right? So okay, I take this and I just the way like the JavaScript engine actually works. It actually takes a bunch of variables you can actually declared and.
Wait,
No, I'm talking about
I didn't
interpreter.
hear you. Like, can you?
Are you trying to differentiate between interpreter and compiler?
Yeah, so I'm trying to
Okay.
explain the reason why the compiler in TypeScript behaves the way it behaves. So the only way you can really understand how it behaves is if you understand the difference, the different way between the different processes between an interpreter and the compiler.
Oh, okay.
So
okay.
yeah, so an interpreter definitely goes line by line. But the way the JavaScript interpreter works is basically it takes like, take for example, you define a var name is equal to Louis or David. At the first time, it actually goes through and takes all the vars and it doesn't pass in the value. So it passes them and renders them as undefined. Then the second time it comes through, it executes and passes in the value. So, but when you're doing anything, it tends to take all those bunch of codes and stores them in memory. So when you pass in, so definitely like it has all the bunch. So if for one reason or the other that you did something else below and you now passed in a string into something that you as an integer, it's going to trigger the error before it actually compiles that code in the JavaScript engine.
Yeah, and
I hope that was like.
Yeah, and that is the reason why when I was starting this, I showed you guys that AST stuff, that abstract syntax tree. Every compiler from Babel and the rest of them, in order to know exactly what is happening in your code, to know what is what, it would generate a JSON structure or a tree. You understand? So with that JSON structure and the tree, you know that if var a equal to 1, it means that 1 is an integer, and that integer is associated with var 1. So any other definition along the project that counters that particular distance, it will throw off an error. Am I making any sense?
Yes.
Yeah, you're making awesome sense.
Or okay, so now to proceed to no, he was talking of different types, right? Babatunde, you were talking of different types in TypeScript, right? So yeah, so like type definitions. Okay, so like if you look at this code now, if you look at line 3 of this code, can you see it?
Yeah.
All right. So this is a definition of the type of this. This is a definition of a type. This is a purely TypeScript construct. purely TypeScript construct. If I take
Is it 31, line 31?
no, line 1. Sorry, line 3. Sorry. Export type valid symbol equal to this. It is a union of this and this. Basically, what this says is whatever is going to take this type called valid symbol, it is going to be either this character or this character. You understand? I might as well be more general. Okay, I could be more general and say valid symbol is string, right? Now any code that sorry, string. All right. So any code that has this definition of valid symbol type means that any string is valid. You understand? But if I put a number or a boolean, TypeScript is going to flag an error. Okay?
Sorry. Yeah, I get you. I think this is basically how the entire programming language that we have today are made up of. Like they try to come up with what is accepted as symbol, then what is accepted as operators, or all those things. Is that what you are trying to explain to us?
No, not really.
Sorry, I don't.
No.
Sorry. I didn't get what Johadi was asking, please.
Okay. So I saw Richard trying to show us valid symbols in this particular context that he's explaining. So I'm now saying that every programming language is actually formed based on this. For example, in PHP, they tell you that if a certain string actually suffix a $sign. For you to declare a variable, it should suffix a string should suffix sign. Then they tell you what kind of operators can be used for equality. Okay, relational operator, or what kind of symbol is accepted for some certain operation, like semicolon and all those things. You get me? And keyword also. So I'm just trying to say that he's trying to tell us to construct a programming language, and he said no, that's not what he's trying to tell us.
All right. Okay. So let me explain.
Do you still get it, Louis?
Yeah, I get what you're saying. So yeah, Richard, what are you trying to say?
All right. So let me do a simple example here. All right.
Okay.
So I have a function called. I call this function get, and this function receives a parameter called user, right? And it returns user, right? So if you look at this code now, TypeScript is flagging my parameter. Sorry. TypeScript is flagging my parameter. But at the same time, it is telling me that it has assigned implicitly a type of any to this parameter. Now, what does this mean? It means that any type of data, whether it is a string, whether it is a number, whether it is a boolean, can be accepted in this parameter, right? But now, what I want in this, my function, is not just any type of parameter. What I want in this, my function, is a string. So I'm going to tell TypeScript, this is the annotation. I'm going to tell TypeScript that this parameter here, it is going to be a string, right? Am I making sense?
Yes.
Okay, so now if you look at if you look at that tooltip now, you'll notice that TypeScript now said that the parameter must be a string, right?
Yes.
Now, if I want to call this function and I call it with a string, no problem, okay? But if I want to call it now with a number, are you guys seeing that red flag? See, argument of type 1 is not assignable to parameter of type string. Are you seeing that?
Yes.
You're seeing that? Now,
Yes.
to come to Johadi's point now. Now, what if I don't want my user to be just any string? What if I want my user to be a specific type of string? Now, this is where this particular stuff that is up here comes into play. With this definition here now, I can come here and say that I don't want any string. I want a string that is a $sign. You understand? I can decide to just type it directly here like this. Okay? I am telling TypeScript that all my types should be $sign. Okay? Now, if I come here, if I put any type of string, there's a flag there. Why? I have told TypeScript that I don't want any type of string. The type of string I want is $sign. Am I making sense? All right. Now,
Yeah.
what if the character you want is not only a $sign, but it is not a general string? You want a $sign and a hash or whatever. You understand? You are using union of. This particular thing that is happening here is a union between two characters, right? So you come here and you tell TypeScript that I want my user to be either a $sign or a hash, right? Now, if I come here and I type my $sign, valid, no flag. If I come here, I type my hash, valid, no flag. But if I come here and I type period or full stop, you see a flag.
So, sorry. I have a question.
Okay.
So, where you're doing the union,
Yeah.
so you specify just two symbols. Like, let's say I want to add another one, like the @ symbol. Can I also chain it?
Yeah,
Okay.
you can. You can chain as much symbols as you want. Yeah. But now the issue is this. This is where I'll talk of interface. What if you have like 100 things you want, but you don't want the whole stuff? You cannot be chaining symbols randomly like that. Now, this is where interface comes in. Interface is a way of configuring all your types, right? Now, if you look at this interface definition here, line 5, can you guys see it? So now this interface definition now you are defining a configuration of your types that you are going to use in your project, it will be easier to manage. Now, in this particular small project that I have here right now, I just have two types. I have this symbol and array. And symbol is defined as this valid symbol and that. You understand? So you don't need to be using that union stuff again, because if you for the application, it can't scale. So now you'll be using interface rather. So now, when you define your whatever function you are using now, that function you use the interface as this thing as the definition. Now let's say we come here now. Instead of my user being those strings, I say my user now is of type my interface. You understand? So now, for this now, I must define an object that looks and acts like that interface. You understand? So if I define an object, hmm? Okay. So if I define an object and I don't put anything inside, TypeScript will not recognize it. Okay? Because as far as TypeScript is concerned, the only thing it recognizes as a valid generate config is anyone that has a symbol, valid symbol, and array, valid array with strings. So it means that symbol should be this, and then array should be this. So notice no flag.
Yeah.
Okay, Louis. David, how about you? You have a question?
I also
Okay. What I want to say is this the union stuff. I see it more like a kind of validation than a kind of type. As a, it's more of we are validating if the user is imputing this. Yeah, so I see it more like TypeScript is like validating for us, like okay, kind of string it is. So generally, type strongly type programming language are like declare a variable, you give it a type. So throughout the life cycle of that variable, it holds that particular, or you declare a function, the parameters of those functions typed. Okay, what is this function receiving? Is it this parameter? Is it a string or a number? You get extra stuff that TypeScript is doing. I see it as validating. Like, so I didn't know if that is just my own.
Okay, but I don't really understand what you mean by the validation. But in terms of type definition, I feel what TypeScript is doing is providing a way to enable you the flexibility to define any type of type for your variable you want. It is not restricting you to the whole this thing. It is saying that it's not every time that you just want a string as the type of your variable. Sometimes for constant definition, like in our Lincoln, you notice status ID. I mean status. The status field in most of those things. for status has either open, match, or match. You understand? So all those things are constants. So with TypeScript now, you can define those ones now as constant using that this thing. Okay, let me just give an example. I can just decide now and say that this my status now should be okay. Type status equal to open, close, matched, on, matched. You notice something? So my status now should be either open, close, matched, or match. Now, when I'm using this, if I give okay, type status, I'm giving this app now, I mean this function now, type status, okay? Now I'm telling TypeScript that any call to get must give either open, close, or this for the status. So if I give anything other than that, you notice no flag. So if I want to make a call to status and I mistakenly put, instead of making a call to status, I mistakenly put David. You are disconnected. How come? Open, enter again. So, Babatunde, am I making any sense? Mm-hmm.
Yes.
So you see the importance of that particular aspect. So now you have restricted your type definition to that. So if somebody mistakenly uses a type other than that, it will throw an error and it will reduce the possibility of bugs in the application. All right. So, sorry. All right. So, Louis. So,
What up?
yeah, you are there. Did you get what I said?
I got every single word you said.
All right. Okay. Any questions before we proceed?
On the TypeScript.
Yeah. On what I've just explained right now.
Explained.
Yeah.
No, not for now.
Okay. All right. So next question. Babatunde says, I read somewhere that TypeScript supports function overloading. I have no idea what that is, which JavaScript doesn't support. What are the usefulness of the feature in TypeScript? Okay. All right. This particular function here does overloading. If you look at line 12, everybody, generate random ID. This function does overloading. What it does is it gives you two different definitions of the parameters of the function. You can either define the function as an object or define the function as a normal parameter. So I know that one is up there is convoluted. So this is what I'm going to do. In this our get function, I'm going to put a union of, I'm going to overload this function, this our get function. I'm going to put a union of generate config. All right. Now, look what is happening here. This is a valid status type, right?
Yes.
It doesn't flag any error. All right. Another type again. You notice something?
Yes, I do.
So you have overloaded this particular function. You can call that function with two different types of parameters. A normal string that is of type status, whatever, you understand? Or
Yes.
an object that is. So now it is left to you now inside your code to manipulate. Now you can use conditional this thing now to say that if this particular this is of type this, performs this series set of actions. If you understand. So
Yes,
so that is the function overloading. So what is your next question? The first one, I'm aware that TypeScript is type, but does it support optional parameters? I think it is similar to, does what I've explained, does it explain the question one? Or am I missing out on something?
Okay. What I'm saying is, what I was thinking is, let's say you have a function that can take 2 parameters, 3 parameters, 4 parameters.
Okay. As in, I understand what you're saying. JavaScript does that. Due to that arguments object, you can define a function with 2 parameters, but it can take 3, depending on how you implement it. But for TypeScript, that particular aspect, I'm not aware. Except it just proceeds with the normal JavaScript stuff that. And also, optional parameters in other programming languages that, like in Python, there's a way you define possibility of extending. Is it not something like that you're referring to? Extending the number of arguments that your function or method.
Okay. It's not as if I don't know the answer to this particular question, but when I was thinking what question was, I just said maybe I should just explain how I understand.
Okay, cool.
So in TypeScript you can have optional parameters. What?
What question did you ask?
Number 1.
Question 1.
Okay, you need to answer.
You didn't answer. You didn't understand or you didn't answer me satisfactorily. So that's why. So
Okay,
okay.
hold on. can it pass an optional parameter to a certain method that you already defined, right?
Okay, let me redefine my question. Like, let's say you defined 3
Parameter.
parameters and you want to make one of them optional. That when the user is calling that particular function, the user doesn't have to supply the third parameter, for example. Now I'm asking if type supports that.
Yeah,
I'm
you
coming.
just use question mark.
I'm coming.
You just use question mark in front of that particular parameter.
That was what I was expecting him to say. Like,
Okay.
put question mark in front of any optional.
In TypeScript,
Yeah.
I'm just knowing about it. But I know that in some other programming languages, what they do, like in Python, they will say like this equal to a particular number. So if that particular argument is not supplied, it will be given that default value.
You can still do that.
It's still possible with JavaScript. You pre-assign the parameter with something.
All right. So even in PHP too. Okay, so Jimo. Fine.
What's up with PHP?
No, those are optional parameters. Yes, most programming languages have it. All right, so decorators. All right, so there are 2 types of decorators that I'm aware of. There is the class decorator, and there is the class decorator, and there is the method decorator. Okay. All right, so I'm going to talk about the class decorator here. At least that particular aspect, I have some understanding of why the method decorators, I'm still not yet clear on what it is. All right, so let me check my app. My app is still working. Okay, so if you see this, line 18, can you guys see line 18?
Yep.
Okay. So what is happening here is this decorator here is, let me, for lack of a better word, decorating app. With this static ID. Because if you look at app, if you look at app, if you look at app, it doesn't have anywhere that ID is defined. Sorry, if you look at app doesn't have anywhere that ID is defined. Okay. So, but the issue is when this main function on line 40, when main function calls, okay, yeah, if you look at app, there is nowhere within the app class that ID is defined. But when you look at main, this main function on line 40, main function takes in a class of a class, and then calls the class with the ID. And then if you look at line 46, main uses app as the parameter, right?
Good question. Kind of things. So, what you are saying is you can actually use the decorator to pass extra parameters to a class.
Exactly.
That's what you're trying to do.
Not parameter. The right word is property.
Let me say extra information.
What about methods?
You can do it. Yeah, you can do it in methods, but I said that I don't understand that aspect yet.
No, that's not what I mean. Go up.
Okay.
Yeah. So in the decorators, you declare ID equals to app, right? Which is a string. Then what I'm asking is, can you assign this ID function?
You can create
function to this ID.
Yes, you can create another property function, and then you can use that function on app. So you are basically decorating. You are adding functions to a class dynamically.
In my own view, again, I think this actually make that component very, very easy.
Exactly.
For example, call it anywhere. You can actually
Make it
pass
very what? Sorry.
readable and very dynamic. Like I'm just trying to emphasize on my own understanding based on what you have said. Which this class app, for example, you can call it somewhere else. Pass extra parameter to that you need in that particular place. Call it in another place. Pass extra parameter that you need in that particular place.
So you don't need
Hi guys.
Yeah, Louis.
So I've already used decorator, so I'm a bit lost here. What I really want to understand is, first of all, you defined decorator component.
Yeah.
I think you are lost.
Yes.
Younger,
So you have ID, you're passing in a string of app. So is this app the same thing as class app, or what is happening here?
No, it is just a normal string. It is a normal string. Yeah, it is a normal string that defines the ID of my div element. Let me show you. So this is my div element. My div element has ID app.
Okay.
So so what if you look at line 40, this main function, it is saying document.getElement by ID, then I'm passing this component class.id. You understand?
ID.
Yeah.
So where is okay, I understand that you have a function main and this is just a normal function, but you're passing an app into it.
Yeah.
So where is ID? So how is that ID getting into that class, the app component?
Yeah. That is the magic of decorators, right?
Okay.
So once you define the decorator, decorators are normal functions.
Okay.
They are normal functions. Yeah. If you look at this utility, this is where my decorator is. Look from line 23 to line 29.
Yep.
So this decorator, it is a function, right? Now this function, this function is taking an object as a parameter, right?
Yes.
Now it is going to return target. Now this target, it is based on the way TypeScript has done it. This target now, it is going to be the class that this decorator is placed on.
Okay.
Let me show you something. Let us say I define this function here. Calm down. Let us say,
I get all this thing. The only thing I want to really understand is the ID itself. What does it do in the app component? That's when you pass it into the main component and it does the get element by ID and does app.id. So what is the ID? What ID would it return from this So,
It returns a string.
okay, of Johade Louis. Is that
No.
what it's going to be returning?
No. It will return. Okay, look at line 21. Can you see line 21?
Mm-hmm. Yes.
ID equal to app. Remember remember I showed you my index.html.
Yes. So it's
Yeah.
an app ID. Okay.
Yeah. So this is the way that I'm telling this JavaScript that I want that particular div.
Okay.
Yeah, I'm going to whatever.
Okay.
Yeah, I'm working with that particular div. So I'm passing it to this get element by ID.
Okay.
Mm.
Okay, now I get what is happening.
Okay, all right.
Yeah.
So, any other question?
No other question.
Guys are going home.